let's pray. In nomine Patris, et Filii, et Spiritus Sancti. Amen. Sancta Michael Arcangelo, defende nos in premio, contra nequitiam et insidias diaboli, esse presidium. Impere ilies, supplicens te precam, tuque princeps militiae celestis, Satanam, aliosque spiritus malignos, qui ad perditionem animarum pervegantur in mundo, divina virtute in infernum disrupt. Amen. In nomine Patris, et Filii, et Spiritus Sancti. Amen. Check this screen and make sure it's good. Good. I can reach that side. Yeah. Good. Yeah, that's it. All right, take out your notes, please. We're going to reboot the notes that were kind of strange yesterday because I had the wrong lesson on my sheet. I'm still trying to figure that one out. But a few things. Solving quadratics. Topic for today, hopefully I'll give you a little bit of time to work. There were two main methods of solving that they covered in the book. I'm going to actually cover 4 of them today. First is with algebra. I'll say parentheses if possible. Second is factor, and I'll ask you what this means in a second. ZPP, if possible. So have your notes out. Please copy this down. Third is complete the square. And the fourth is something called the quadratic formula. The book is also going to ask you to use what's called the discriminant. I'll tell you what that means a little later. So go ahead and write those down. The 4 standard methods, the 4 common methods of solving quadratics are algebra, if possible, factor and CPP, I'll ask somebody what that means in a moment, if possible, complete the square, and quadratic formulas. There are other methods, but they're really big and intense and usually not used for something as small as a quadratic. First things first, someone please tell me what a quadratic is. What is a quadratic? Yeah, it's a word we're going to talk about. Yeah, please. No death penalty for being wrong. Go ahead. Take the plunge. I think you're going to say it. It is a polynomial with a special characteristic. There's something about its degree. Yeah. Degree of 2. A quadratic is a polynomial or something with a degree of 2. Which begs the question, what's a degree? In geometry, that's how big an angle is. In physical science, that's how much temperature you have. Yeah. It's the highest exponent. Degree means the highest exponent. I'll say the highest variable's exponent. So in other words, if I have 5 to the 10th power plus x to the 3rd plus x squared, this would be the degree. 10 would not be the degree here, because that's not really an exponent. 5 to the 10th power you can actually calculate. I don't know if it is something huge, but you can actually calculate it down to an actual number without a power. This, you're stuck with the power. Okay? So whatever the highest actual exponent is, that's called the degree. And if the highest degree in the entire problem is 2, you're looking at something called a quadratic. If you graph it, it's usually a parabola shape, or U shape. Not always, but usually. Questions, Mark? Those are the basic definitions. Algebra, if possible. Example number 1. Can somebody tell me when you use algebra to solve pretty much anything? Sometimes you can and sometimes you can't. Yeah. Correct. This only algebra, you can solve. Is everybody good with W slash meaning with? Okay, solve with algebra only if there's one species, or what kind, species of X. And by species, I mean power. If there's only one type of power of X, you can use algebra to solve. This particular one up here, you could not use algebra, because there are two distinct different powers of X, cubed and squared. If all of them are cubed, or if all of them are squared, you can use algebra. Quick example. 7x squared plus 5x squared minus 10 is equal to, yeah, why not? 134. Solve. How? Where do you start? Let me see. Okay, help me out here. How do you start this problem? Right, that would be smart. Simplify before you solve makes your problem simpler, hence the name. What would that give you? 12x squared minus 10 equals 134. What would you do next? Right, whatever's farthest away from the variable, get rid of that first. Add 10, 12x squared equals 140. Okay, Spencer, take over. I would, but there's something further away than the square. What do you get rid of first? Yes, divide by 12. Because the 12 is further away than the square is. The square is pretty much sitting on X's head. It's about as close as you can get. What do you get?
You get X squared
Equals 12. Okay, Will, take over. How do you solve for X? Sorry about the leaning tower piece that you went there.
You just square root it.
Square rooted. How many answers? 2. What kind?
Positive.
Positive or negative? Does this reduce square root of 12?
Yeah. You can do square root of 4.
Yes, times the square root of 3. And how do you deal with square root apart from a radical?
Oh shoot. Square root has 2 answers.
Correct. What do you put in front?
Like just a plus or minus.
Plus minus. That's what keeps it apart. So plus or minus square root of 4 times square root of 3. So what is that really when you boil it down?
2 square root times the square root of 3.
Yeah, plus or minus 2 times the square root of 3. And those are your solutions. That's using algebra. So you basically square rooting both sides. That only works if you have one species or one type of power of X. If you have more than one power, this will not work. Because if you try and square root square, it makes a mess out of cube. Try and cube root it makes a mess out of square. Example number 2. It's been a while since we've done one of these. 6x squared plus 7x plus negative 3 equals 0. Solve for X. How? Seems rather stiff and challenging. Josh, name me what's the first type of factoring? There's 7 different types of basic factoring. What's the first one you always look for? Before anything else? Okay, Nate. GCF. Then after that, comes after GCF. Let me list these. So GCF, Nate, go ahead. That comes a little later. Yeah, same. Starts with a U. Unfoil. Then comes what? Liz. Starts with B. That helps. Binomial squared. What comes after that? Courtney. Starts with D. Multiple words. Beyond it.
Oh, difference of
Got it.
two squares.
Difference of two squares. We got 1, 2, 3, 4. The fifth one I heard earlier. Go. Grouping. What's the sixth? Go. Magic pair. Anybody who's never had me before, I can get to show you what that does. And Sam? Substitution. Now, GCF works anytime there's a GCF. You just pull it out in front. What if the first term is negative? Yes.
Pull out there in GCF.
Pull out a negative GCF, correct. Unfoil. There's a code for knowing when unfoil works. It's, oh, this is gonna go off screen, I won't be able to see. Unfoil, I'll just put it over here. Unfoil works if, quote unquote, 3, 2, 1. 3, 2, 1. 3 what, 2 what, 1 what? What do those stand for? Please. Three terms.
Degree of 2.
Degree of 2.
And one, oops.
Yeah, 1 in front, coefficient. So if the lead coefficient in front of x squared is 1, and if the degree is 2 and there are 3 terms, you can try unfoil. For example, unfoil looks like this. This is kind of the most common method you'll ever run into. X squared plus 5x plus 6. Unfoil says, you notice there's a 1 in front, degree of 2, 3 terms. So we can try it. What two numbers add up to 5 and multiply to be 6? Mary. 2 and 3. So what would this be? Anyway, what would you write, like the whole thing? Go.
X plus 2,
X plus 2, x plus 3. Because the x squared has to split into x times x. The 6 splits into 2 times 3, but they add up to 5. So find two numbers that, it's always x and x for unfoil. And then two numbers that add up to 5 multiplied by 6. That's called unfoil. It's the undoing of foil. Binomial squared is a 3-step pattern for binomial squared. Can somebody name it for me? Mary Claire? Yeah, square the first, double the product, square the last. Factoring with binomial squared means going backwards for that. For example, 4x squared plus, let me see, 24x plus 9. Can somebody tell me if this is a binomial squared? If so, what? If not, why not? Nick.
What are the 3 rules for binomial?
It's square the first, double the product, square the last. So square the first, double the product, square the last. What they mean is that there are 2 terms, theoretically. A binomial means 2 terms. So it's a binomial, the first and the last. You square the first, should be this. Double the product should be this. And square the last should be this. Can you take an educated guess as to what would go here? If this is squared the first, what did they square?
Square 2.
And
2x.
Exactly, 2x. At least in theory, that's all you need to do there. Where did this come from? Square the last.
So 3.
3. It could be 3, it could be negative 3. So let's check it. Square the first, double the product, square the last. Does it work? Okay.
No.
It does not. What's wrong? It was so close. This is the normal technique you do it. Just grab from the first, grab from the last, and hopefully you're done. But you have to use the middle term to check your answer. What's wrong? Yeah.
It should be 6x.
It should be what?
6x.
Yeah. Well, 2x times 3 is what? Then double it. This should be 12x, not 24. So this was so close, but it failed. But that's the technique. That's how you factor with binomial squared. If this were 4x squared plus 12x plus 9, it would have worked like a charm. Clear? Gentlemen? Lost your chat. Clear on that? This is what we call prime. Prime means it does not factor. We stop with that. Factor by grouping. When do you do that? Go, Josh.
There's 4.
If there's 4 terms, correct. I'm gonna do a quick example of that one. Example number, oh, I skipped difference 2 squares. I'm gonna need it. Hang on a second. Let me skip back to number 4. Can somebody factor this for me? X squared minus 100. You'll notice it's a square minus a square. Go, come here, Claire. Correct. Anytime you have a square minus a square, it falls into x and x, plus minus, it's always 1 plus and 1 minus, and then it's 10 and 10. Splits evenly, multiply once. Does that look familiar? Stay with me. Now, jumping to grouping. This was for example number 4. Example number 5. Try this. X cubed plus 6x squared plus 2x plus 12. No one know if that factors. Spencer, try this one. What method would you try?
No.
Grouping, why?
So there's 4 terms.
There's 4 terms. How does it work?
You can parentheses on 2.
Yeah, parentheses are on the first 2, or on the last 2. Now, double check something for me. Is there a GCF overall? No, there is not. I mean, other than 1, which is boring. So there's no GCF. If you group the first pair, don't capture the parentheses, the plus sign here in the parentheses. And group the last. Is there a little miniature GCF just in this pair? What would you think?
X squared.
X squared. What's left behind if you pull that out?
X
X
plus 6.
plus 6. Is that okay? That's all right. And then how about the next one?
Plus
2 parentheses.
X plus 6.
Notice anything about parentheses?
Same.
They're the same. Sam, take over. Is this thing gonna work? What do you do? Yeah. You notice how the x squared was a common factor, so you pull it out in front. The 2 was a common factor, so you pull it out in front. Look at the parentheses. That's a common factor. The same thing is multiplied to both. X squared is multiplied to these. 2 is multiplied to these. X plus 6 is multiplied to these. So you're going to factor the x plus 6 out in front. What's left behind? X squared plus 2. And you're done. That's factor by group. Okay. Seem familiar? Hopefully. Now, this piece. 6x squared plus 7x plus negative 3. Go down the list and check. GCF. Let me see. Shirley, is there a GCF in this thing?
No.
Nothing of use. Can we unfoil?
No.
Why not?
Because it has three terms. It has the degree of 2, but
It does not have a 1 in front of the x squared, it has a 6. So it's spoiled front FOIL. Know where I'm heading. What about, Mary, binomial squared? Does it seem to fit square the first double product, square the last? Does it look like they squared something to get this, doubled the product to get this, and squared the last to get this? Or not? What would your instinct be? That's correct. Can you tell me one thing that'd be wrong? Because if you do, I'll give you a quick example. 2x plus 5 parentheses squared would give you 4x squared plus 2x and 5 is 10x, doubled is 20x, and then 25 is square the last.
You can't square something with 6.
Yeah, can't square rid of anything. You can't square anything nice and get 6, and there's something even worse. Yeah, that's definitely a problem.
And you can't square anything with
And get what?
to get 3.
Actually, what kind of 3?
Negative 3.
Squaring to get a negative is a naughty. You can't do that. Unless the number is what kind of number? We were playing with it earlier. Imaginary, right. We'll cut to that later. But in other words, this is a disaster for binomial squared. Skip over it. Can I do difference of 2 squares? Well, does this fit difference of 2 squares? Difference of 2 squares looks like this.
No.
Why not? There's something immediately obviously wrong.
Because.
When do you use difference of 2 squares?
There's 2 terms.
Exactly. How many do we have here?
3.
Game over. It has to have two terms with a minus sign in between for difference of 2 squares to work. Not so much. Can we factor by grouping? Nate? Why not? Not 4 terms. Factor by grouping looks like this. 4 terms grouped into 2 and 2. It is possible to do factor by grouping with bigger things, but like 6 terms, 8 terms, an even number of terms. Not so much. All the methods we've had so far have failed. Can anybody tell me how to factor by magic pair? What's step 1? If you've never seen this method before, jot it down. It's when I went to high school, they did not have this method. It was guess or check, which you can get pretty good at it after a while. But this is an actual step-by-step, what's called an algorithm. Yeah.
Don't you like take both end terms and
Yes. Take the first term and last term and do what?
multiply?
Multiply them. What do you get?
Negative 18.
Negative 18x squared. Good.
Like-
That's step 1. Take the first and last term and multiply them. That's step 1. Draw a little line under that. What are we about to do? Austin. What do we do here? Magic pair. So we multiplied the first and last, got negative 18x squared. It's a yes. Find the multiplied pairs. They're called factor pairs. Make sure each one has an x. For example, here's the first one. 1x times negative 18x. 2x times, go ahead and keep going to that one. What would it be?
Negative 9x.
Keep going. Is there anything else? 3x times negative 6x. 4 doesn't work. 5 doesn't work. Quick question. Go for it. Put it back. And make sure the door block stays in there. Otherwise it locks behind you. Go ahead.
And then it'll start with 9x.
Actually, you missed one.
I'm sorry, 6x times negative 3x.
6x times negative 3x. Quick question. Is that a repeat? Up the one above it?
No, since there's the negative.
Right. This is negative 6. It's positive 6. Keep going.
And then 9x times negative 2x.
9x times negative 2x.
18x times negative x.
These are called factor pairs. Factor means to break apart. In math, it means to break apart using multiplication. list all the factor pairs. By the way, if you know it in your head, okay. But as a general rule, list them all out. There can be a long list. What am I looking for? Please.
Like the pair ends up to be the
Yeah, whichever one adds up to the middle term, 7x. It's a little like unfoiled in that way. Do any of these actually add up to 7x?
9x and
The one near the bottom here. This is what we call the magic pair. How do you know that's the right one again?
does it add to 7x?
9x plus negative 2x does add up to 7x. That's how we know. Everybody please do this. Grab your writing utensil. You see the times here? Manually change it to plus. What are we about to do with that? Jim.
Going to substitute in for 7x.
Right. We know it adds up to 7x, so we should be able to replace 7x with it. Tell me what that looks like.
It's going to be 6x squared plus 9x plus negative 2x minus 3.
Yeah, plus negative, either way. 6x squared plus 9x plus negative 2x plus negative 3. Now, that actually just makes it look worse. It's now 4 terms instead of 3. What's the advantage now? Yeah, you can factor by grouping. And by the way, if a magic pair exists, factor by grouping will always work. It's not anyway. Somebody do it for me? Who's feeling creative or brave? Okay. Is there a GCF in here, a little mini?
Yeah,
3x, what's left behind? 2x plus 3, looks good. Plus what? Negative. Negative what?
1.
Nice. If the first term's negative, pull out a negative GCF. What's left behind?
2x plus 3.
Gentlemen, please don't chit-chat with each other. Is this gonna work? Yeah. The parentheses match, so what do you do with it? Right. Pull the 2x plus 3 out in front. So you have 2x plus 3, and then give me a parentheses for the leftovers.
3x minus 1.
Yeah. Or the plus negative 1, whichever you like. And you're done factoring. Okay? So that's the 6th type of factoring. We're going to skip substitution for now because it's optional and it's kind of exotic. I'll show you later on this week if you don't remember it. But for right now, I need to show you 2 other techniques. Algebra is when you take the square root of both sides. You can only do that if you have a single species of x. Then factor and what's CPP? Yeah. That's the zero product property. Let me get this thing out of here. Can somebody tell me what the zero product property is? Because you notice I just factored this, but I didn't solve. I didn't get x equals. So let me write this again. 6x squared plus 7x plus negative 3 equals 0. And you found the factors. It's 2x plus 3, 3x minus 1 equals 0. How do you solve something that looks like this? Something times something equals 0. What does the zero product property do? Courtney, help me out. How do you do with something times something equals 0?
You have to split it up.
Yes. What does it look like?
So 2x plus 3 equals 0.
2x plus 3 equals 0?
And then 3x minus 1.
Or 3x minus 1 equals 0. This is on the principle, if you haven't seen the zero product property, let me write this here. Zero product property states the following. If a times b is equal to 0, that means if you have any 2 random numbers equal to 0, when you multiply them, then something must be true. What happens when you multiply 2 numbers and you get an answer of 0? What must be true? Like, what's the only way you can have that happen? Go, Joe. One of them has to be 0. Because when you multiply by 0, that's the only way to kill it, to get 0. Then either A is 0, or B is 0, or both. That's the zero product property. And you can extend that beyond 2 letters. You could have A, B, C equals 0, set them all equal to 0. You could have 10 letters, set all 10 equal to 0. So that's what I did here. Pretend this first letter, parentheses is A and the second parentheses is B, and you'll see what's happening. You notice we now have two miniature problems which are much easier to solve. So Katie, take over, solve this for me.
So you have 3.
Sorry?
Sorry,
Minus 3. What do you have so far?
2x equals -3.
2x equals -3. Keep going.
Divide by 2.
Divide by 2. What do you get? X equals?
-2.
Correct. You do not need to move it into a mixed number. I would actually rather you not. You could, I won't take up any points if you do -1.5, but I'd actually like you to leave it as a fraction. It's easier on you, and it's actually easier on me, because if I ask you in the next problem, good, now take that answer and multiply it by 8, you're gonna need it in this form anyway. Multiplying a mixed number by a number, you can't do it directly, you have to switch it into an improper fraction. And, Kelly, help me out with this one.
No, you add 1 to both sides.
Okay, what do you have so far?
3x equals 1.
Okay,
Divide by 3.
divide by 3,
X equals 1/3.
x equals 1/3. And that's how you solve this. Okay. So those are the 6 standard ways you can expect to solve using factoring for a quadratic. Any questions so far? Okay. I want to keep that up for just a second. Is everybody okay with this? The factoring one? Okay. Now, complete the square. It's been a while. There are 5 steps to completing the square. Now, we're assuming you start with ax squared plus bx plus c equals 0. That's called standard form of quadratic. So a, b, and c are numbers. So a is a number, b is a number, c is a number. So like 3x squared plus 4x plus 5 equals 0. Okay. Step 1. Set it equal to 0 if needed. Sometimes it's already equal to 0, in which case, great, you can skip this. Step 2. Cancel the c to the other side, comma, and leave a blank. I'll give you a demo of this in a second. For now, just write down the words. So step 1 is set it equal to 0 if it needs to happen. And then step 2 is cancel the c to the other side. They usually mean subtracting. But cancel the c to the other side and leave a blank. 3. Undistribute the a. Distributing means multiplying into multiple terms. Undistributing means to divide it back out in front. Kind of like taking a GC out. 4. Complete the, and I'm going to abbreviate it here. BIN is short for binomial. Complete the binomial squared and balance the other side. Oops. Complete the binomial squared and balance the other side. And 5. There are 2 options here. 5a, 5b. 5a is if you want to graph. 5b is if you want to solve. 5a, get it back equal to 0. And then replace the y equals in front. We'll probably talk about that tomorrow. Right now we're focusing on solving. to solve with algebra. So you have a choice on 5A or 5B, depending on if you want to graph or if you want to solve. Okay. Let me clear this stuff out. Let's say I want to solve something by completing the square. Solve by complete the square. I'm going to abbreviate it for so let's say that. And I'm going to say y equals 2x squared plus 12x plus, hang on a second. 17. Go ahead and write that down. Can someone refresh my memory? What does it mean to solve? Like y equals means you're going to graph. What code means you're going to solve?
Equals 0.
That's actually why the step 1 is step 1. Set it equal to 0. We're really just setting y equal to 0. We're replacing y with 0. So 2x squared plus 12x plus 17 equals 0. That's step 1. You're 20% of the way done just by doing that. Now, can somebody tell me how to get step 2? Those are the steps. What does it look like in this case? Go. Exactly. Subtract 17. I'll explain why we're doing this in a minute, but for right now, as long as you do it to both sides. And what I'd like you to do is do 2x squared plus 12x, and then leave a plus blank. And then what's 0 minus 17? It's, what's this? Negative 17. Leave a blank there. Everything smart? So step 1, set it equal to 0. Step 2, cancel the c, which in this case is, because this is like ax squared plus bx plus c. And leave a blank. Step 3, Sam.
Pull the 2 out.
Pull the 2 out, correct. What does it look like when you do that? 2 parentheses what?
X squared plus 6x.
Yeah, plus 6x plus blank, parentheses equals, right. Does that make sense? If you remember, there's a 3-step pattern for binomial squared. And that's why I nagged you on it last year, and why I'm nagging you this year. Square the first, double the product, square the last. It's not just a shortcut for taking a binomial and squaring it, although it is. I want this thing to look like a binomial squared. I want this to look like a squared first, this to look like a double product, this to look like a squared last, and it doesn't. I'll say this one is the only one that could have been close. Double the product, yeah, I can see that. 6x and 6x. Square the first, this is half good and half bad. Can somebody explain? If this is a square the first, what's good about it, what's bad about it? Yeah, very good. The x is squared, I like the x squared 2. Yeah. If it had been 4x squared, I would have said, that's great. 9x squared, 100x squared, a perfect square, great. The 2x squared is half good, x squared, and half bad. I also want this last thing to be the square of the last. That's a disaster. You'd have to have the square root of 17. Yep. So in other words, good, half bad, rotten. So which one would I want to get rid of first? You open up the fridge. There is an avocado that's perfectly fresh, an avocado that's a little squishy, you could cut off the squishy parts, and an avocado that's so disgustingly decayed that it's probably going to start moving on its own in a few days. Which do you get rid of first? Yeah, thank you. I mean, I shouldn't take this long. Like, oh, I keep it for an experiment. No, not in my house. No. So in other words, this is the worst. Get rid of it first. That's exactly what it did. Then the 2 is the rotten part. I get rid of that. I'm peeling off everything that doesn't fit. Square the first, double product, square the last. And by the way, you notice the inside stuff? It's looking pretty good. That looks like a squared first. That looks like a double product. That, not so much, but we'll fix that out. Step 4. I would like you to, sometimes instead of the word complete, I sometimes use the word compress. Actually, this is a true story. Well, a general story. When I pack a suitcase, I think I do a relatively decent job. But for whatever reason, my wife, I mean, maybe this is something that women are better at than men. She can pack twice as much stuff into a suitcase than I can. I mean, if I put that much stuff in, I would have to sit on it and hold dumbbells on my lap in order to get the thing to close. And then by the time I get to the hotel and I spring the thing, poof! Good luck getting it ever back in. Now, if she packs it for me, kind of the same thing happens. I open it, doesn't explode. But once I actually wear the stuff, it's like, how do I get it back in? I can't. It's like, how is it? Hi, honey. How? Can you tell me how to pack my suitcase? This is true. So I think what she rolls up some of it, whatever. But you can have a lot of stuff compressed into a small area. Watch this. X squared plus 10x plus 25. I'm going to compress this. The suitcase is now closed. It's taking up less space. But you see that they're the same thing? Square the first, double the product, square the last. And if you have any doubt, go ahead and multiply x plus 5 times x plus 5. You will get this. These are identical, just one takes up less room. This is what I mean by compress. I want to take this, not the 2, but the thing inside, and compress it into a binomial square. You tell me, oh math people. Nate, where did this come from? Yeah, it came from x, and then plus what? Where'd you get the 3 from? Because I would have loved to do square the last, but it doesn't have one. Yeah, what's the second step in a binomial squared, Blaze? Square the first, double the product. What's x times 3? Anyway. 3x, double it. 6x. I want 6x. So what you do, here's the shortcut. The number in the middle, cut it in half. Don't put 3x, just 3. I've already got an x. Now, go back in time and tell me what this number should have been. Square the first, double the product, square the last. Right, what should be 9, exactly. Never right so far. I'm about to do something that's critically important, but relatively easy if you follow. Do you see this 9 that just appeared out of nowhere? That's what I call, like you have a teeter-totter or something, that's extra weight. Here's the equal sign, here's the left-hand side, the right-hand side. You just put 9 extra pounds on the left-hand side. How do you balance it? Yeah. Put 9 pounds on the other side. Sorta, kinda. Look up here. There's a little bit of a catch. You're right. It looks like I should do this. That looks like that should fix everything. However, does anybody see one little detail? It's twice as big as you thought it was. Everything's times 2. So what do you really multiply adding? Add 18. Twice as big as this, which is 18. Now go ahead and add those up. It's 1. Equals 1. And by the way, this should be a binomial what? Squared. Congratulations. The main part of complete the square is done. One more step. Do you see how we got this? This monstrosity here, 2x squared plus 12x plus 17, is identical to this. This is just taking up less room. Now a question. For today, did we want to solve or graph? Just, here, go, John. Yeah, we want to solve. Yeah. So what do? Which step do I use? 5A or 5B? Sam? 5B. Solve with algebra. You can only solve with algebra if what? Go.
There's
One species of x. I thought we didn't. There's like squared and regular. Can we solve with algebra? Yes. We only have one species of x left. Presto, change or nothing up my sleeve. Tell me how to solve this. Well, math people. 2 parentheses x plus 3 quantity squared equals 1. Tell me what to do. Oh, math whizzes. Mary. I want to get x by itself. What would you get rid of first? Yes, divide by 2. Don't square root it yet because the 2 is further away. As long as you do it to both sides. So we now have x plus 3 parentheses squared equals what? 1/2, correct. Now what, Jaylee?
You have to square root it.
Square root it. How many answers?
2.
2. What kind?
Positive, negative.
Positive, negative. This is going to be totally fun, by the way. You said it somewhat sarcastically. So what happens over here, Katie?
So just do x plus 3.
Yeah, the square and the square root cancel. This is x plus 3 equals plus or minus what? How do you do the square root of 1 over 2? How does that work? How do you square root a fraction? Go. Yeah, square root the top, square root the bottom. What is the square root of 1, by the way? Don't worry too hard. It's 1. What's wrong with leaving it like that? It's got a radical in the basement. Fix it. What is that then? Square root of 2 over 2. That's exactly what I want to do. Where was it? Here. Everybody with me? Now, I want x by itself. One last step will do it. Wait. How do you get x by itself? Subtract 3 from both sides. My recommendation, look up here visually. If I do minus 3 on this side, people might get confused. They say plus or minus this. Is this plus or minus the minus? I would actually have it butt in line. Put it in front. X equals negative 3 plus or minus the square root of 2 over 2. And you are looking at your solutions. That's solving by completing the square. Still with me? I know, especially if you haven't thought of this for a while, or if you haven't seen this before at all, this can be kind of drinking from a fire hose. It's kind of like, I don't know if you've ever done it. I've never actually done it, but I understand it would be really, really intense. I don't. Have you ever seen a fire hose in action? There's like hundreds of gallons of water per second. It's like, you try and drink out of it, you'll explode. Or your face will be in the next county and the rest of you will be here. Because there's a lot of pressure. So I don't want to put you under a lot of pressure. So I want to slow things down. There is actually going to be, don't get used to this, one more day without homework. Because I need to finish, I've got a little bit more notes today. Not much. But I need to at least touch on the quadratic formula. And then tomorrow I'll try and give you some time to work. Because we'll have the vast majority of the notes done. If you have never seen complete the square before, try practicing. Practice with a bunch of different random number polynomials. Quadratics. Example 4. People who had me last year, I had you memorize this for extra credit points. They had to recite it in 5 seconds or less in order to get +5 extra credit on their next chapter test. Can anybody still do it in less than 5 seconds? X equals? negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. And slightly faster, x equals negative b plus or minus square root of b squared minus 4ac, all divided by 2a. So, there's a story behind that. If you haven't been with me as a teacher before, I'll tell you the story tomorrow. But for now, this will solve, well, sorry, that was horrible. It solves ax squared plus bx plus c equals 0. And it solves it in one step. It's a big, ugly formula. Well, it's a big, beautiful formula. But it solves this in one step rather than 5. And it solves it relatively, it's one of the faster ways to solve these things. Factoring can be faster. Square rooting, if you can do it, is very fast. But this is a pretty good trick to have in your belt. The quadratic formula. I will show you where it came from tomorrow. And then we'll use it. And then there are a couple of things. I do want you to indicate, this will be the last notes for today. Circle the b squared minus 4ac. It has a special nickname. B squared minus 4ac, not the square root of it, but just the b squared minus 4ac, is called the discriminant. And it has some very special powers, and I will tell you what those powers are tomorrow. Good enough? All right, we're almost out of time, so let your brains cool off for a few minutes. Well done. People at home, this is my hand waving bye. Talk to you later.